Okay, we'll be starting with the session now, and then let everyone join as we proceed with the session. First of all, welcome everyone. Thank you for joining us here today. I'm Manish Nath from Hex-Star Universe, and I'll be your host for today's session. Today, we have a really exciting session for everyone, where we'll be talking about AI/ML in space technology. And I hope everyone is really excited about this session. So proceed with our session for today. Our topic for today's session is evolution of AI/ML and its effect on space technology. And to enlighten us on this topic, we have none other than Mrs. Professor Sabyasachi Mukhopadhyay here with us. He is a Ph.D. research scholar from IIT Kharagpur and also a visiting faculty of IoT at the Department of IT in University of Calcutta, and a former data scientist, and also a TEDx speaker in the past. We are really glad to have him here with us today. So without any further ado, I'd like to request Professor Sabyasachi to proceed to this session. Thank you, everyone. Sir, I'm really sorry to interrupt, but your voice is cracking and it's not really clearly audible. Sir, it is still not clearly audible.
Hello?
No, sir. So it's still not clearly audible.
Some network issue is going on, I guess. Okay, I hope
Yes.
now I am back to the network connect. Okay, so what I
Yes.
was saying that now today's topic we will discuss about the AI and ML space technology using magic areas. And I believe those who are new to this field, it might help them to explore in this field.
So I'm again really sorry to interrupt, but it is still not clearly audible.
So, hello.
Yes, sir. Hi everyone, I think sir is facing some network issue, so we will be waiting for a few minutes so that sir can join again, and then we'll be proceeding with the session again.
Hello, am I audible?
Yes, sir.
Okay, sorry to everyone. Unfortunately, I got disconnected. Okay, so let me share the screen with all of you. Is the screen visible to all of you?
Yes, sir.
Okay, so today we are going to check what are the present roles of AI in space technologies. So can you see the screen slide movement there? Is it clearly visible?
So I think you are sharing the Google tab, so we cannot see the slides.
Just Is it visible now? Can you
Yes,
see
sir,
the
it is
screen?
visible.
Okay, thank you.
Yes.
So first of all, we shall start with what is AI. So basically, the era of AI has started right from the 1950s with John McCarthy, but in 1945, actually, the idea of the mimicking human activity has started, okay, which we call the AI. So basically, the explorations of machine learning technologies, okay, along with their gradually how can we mimic the human activities, that gradually started with the simulation of the human intelligence, which can be done with the machines, especially in the computer systems. But gradually with the proceedings of the 1960s era, we have seen the gradual arrival of the certain concepts, okay, like the neural network followed by the generation basic formulation of the support vector machine, and along with that gradually the automation era, robotics era parallelly started. And all of you know that in 1980s, the major influence which we got, the basics, that is the open source era. And now what are the Pythonic platforms, Java, whatever we are using nowadays, these all are basically the blessings of the open source era. Okay, and then gradually what happened that during the late 80s, although the deep learning framework has started to explore like the Linux, but it could not do well because of the problematic scenario, like for examples, they have Jan LeCun at that period of time, they have used the sigmoid function, so that did not work at that period of time. So as an activation function, so Lenet failed miserably, and in that period of time, the dominance of decision tree support vector machine, these are the state-of-art AI technologies or ML technologies has explored a lot. But what happened that in the late 90s, okay, we have seen that there are apart from the structured data, okay, we have seen the rise of the semi-structured data as well, where you have the structured part as well as, for example, along with the tabular data set, we have the image data set. Okay, so for example, if you are posting something in Facebook, sending some email, so your login time, logout time, and the activity time, this remains in a structured format. But the image, videos, okay, this remains in an unstructured format. So these are basically the part of the semi-structured data. And holistically, you are generating the semi-structured data. So the era of the web 1.2 and 2.2 all are being dominated by the semi-structured data and the cloud-centric data. So that has given us a lot of opportunity to solving complex problems, as you can see in the screen, decision making in terms of increasing accuracy and handling the high-level computational problem. Okay, so this has given us a lot of opportunity, bandwidth in every domain, whether it is biophotonics or the biomedical imaging, whether it is astrophysics or space sciences, or whether we are talking about any management domain as well, marketing analytics, financial analytics, everywhere you can see the swatch of this kind of the applications. Okay, so due to that reason, every domain, whether they are the social scientist or the space scientist or normal AIML applicants, researchers, technologists, they all are trying to figure out what we can harness from the data. Okay, so that data can help you in terms of the elegant decision-making process. Now, the thing is that whenever we are talking about the space sciences, okay, so what are the major areas which the scientists are gradually focusing on? That we have to check. So if you see this world, as per the scientist explorations till date, we only have seen the 4% of the visible universe, okay, which is made up of the stars, galaxies, okay, astronomical objects, planets, only the 4%. Okay, but the remaining, the 96% is still left unexplored. So can the applications of the AI help us to explore on those directions? So that would be the major aspect to check, that can we explore this 96% of the remaining part, where we can check out the possibilities of AI-based applications. Okay, so the first image of the black hole generation, which has been done. Okay, the first of the areas of the one of the areas, promising areas, was the generation of the black hole image with the help of the chirp algorithm, which is basically a Bayesian process. Okay, so this was what was the work done by the MIT's computer science and the artificial intelligence team. So the good thing is about that, all of you know that it has been captured with the Event Horizon telescopes. But those who are very much accustomed with the Pythonic platform, they know that, for example, NumPy, Pandas, these libraries have been used for this data, figuring out the scale down the data, okay, correlation of the data, calibration of the data, then followed by the ML has been explored for the image analysis purpose. So the NumPy, Pandas, and the other Pythonic libraries have been used a lot to generate these black hole images. That is a very good sign. And if you see, the image courtesy goes to National Geographic channel. So basically they have provided us this black hole image. So you can check out, this is the first explorations of the Pythonic platform. All of you know that there are a lot of Pythonic platforms are available here, although NumPy, SciPy, these are used, Pandas are used. But in generally, whenever you are even using the machine learning or deep learning frameworks, that all of you are quite aware that there are the Pythonic platforms like TensorFlow, PyTorch, Keras, these are available. So the Python and Pythonic platforms plays a very pivotal role in terms of those who are very much keen to build their career in the data science domain. Okay, because nowadays from the 2012 onwards, we are getting the support of the GPU, which is the major reason for the success of the deep learning era. Right? Why this is why the AlexNet actually able to beat the LeNet and other existing machine learning algorithms. So from that, we have seen in 2015 Google came up with the we have seen the GPU. Google came up with TPU in 2015. So gradually the data strength and data processing strength has increased, and that's the reason we can see the high volume data set in space science domain explorations become quite easier. Okay, so now if we see, like I was mentioning, that the SciPy, Pandas, also the integral part of this, along with the NumPy, was this generation of the pipeline of the black hole image. So if we see the standard astronomical file format, which is being handled by the Astropy, and all of you know the Matplotlib, okay, that is very much elegant tool to visualize this kind of the pipeline. Okay, so that we can get the generation of the final image of the black hole. Okay, so scientists and researchers are also working towards the generation of the more accurate image of the black hole. That was an approximated image. They are trying to generate the more accurate image. And to do so, they're also coming up with some of the complex algorithms using the machine learning, deep learning, as well as artificial intelligence. So that was the first part which we have explored in terms of the black hole image generation. And second one, which we are going to discuss, the AI-based assistants and robots. Okay, that also has the great role in terms of the space science applications. Okay, so I believe all of you can see the slide movements. In case if you can feel that you are unable to see the slides, please let me know, because I do not know whether my net is working properly or not. So your active cooperation is also required. So anyway, so AI-based. Hello.
Yes, sir. So I'm sorry to interrupt.
Am I audible?
Yes, sir.
Yes.
But we had only seen the first slide. So are you have you proceeded with the slides? Because
Yes, I am just. That's the reason I asked you. In that case, if you can't see the slide movement visibility, so let me what I can do, as there are a lot of disturbances in terms of the in internet issue. I am clicking the slides one by one, and then I am just delivering my talk. I think it will be better because I can see if I go to the slide sharing mode. So what is happening that you can't see the slide movement. Okay, so
okay.
Just a second. Can you see this slide now?
So I think you are still not sharing the screen. So, yes, sir. Now we can see.
Okay, so what I'm doing, I'm just going one, as I have already explained this AI part, so just I'm going through the slides again, as you have not been able to see. So if I am clicking the slides one by one, is it visible to all of you?
Yes, sir. Now
I think now you can see it, right? Because
yes.
okay, because whenever I am going to the slide sharing mode, you can't see the slide movements. Okay, no problem. So like I mentioned earlier, that the big concept of AI, the simulation of human intelligence just by machines, and especially in the computer system, the over the year I give you the highlight of the how we are processing the structured, semi-structured, and the unstructured data. Okay, and the flourishment of the open source era Pythonic platform, and due to that you are getting TensorFlow, PyTorch, this kind of the applications in the explorations of the machine learning and deep learning era, and the way it is being useful in terms of the decision making or solving complex problems, the increasing of the high performance level computations. So first applications which we have discussed so far, that is the related to the black hole image. Okay, because 96% of the universe is still unexplored. So how, with the help of the AI-based technologies, can help us in terms of the exploring that area? So this particular case, this particular type of the image of the black hole was generated by the CHIRP, which is an AI Bayesian algorithm. Okay, and the Event Horizons telescope was used at that period of time. So NumPy, Pandas, and the other Pythonic platform has been used to generate this black hole image. Okay. So if we see, for example, apart from this SciPy, Pandas, and the NumPy, another part that was used for the time coordinate formulations and the astronomical file formats, that was handled by the Astropy. Okay, and along with the Astropy, we have also seen the Matplotlib that was also explored in terms of the visualizing the data throughout the analysis pipeline, which can generate the final black hole image. Although this is they have tried their level best to produce the best image, but still the scientists are trying to give you the much more accurate image. Okay, and all those complex algorithms that can be explored with the help of the AI/ML, and to see, like I told you, that the 96% of the universe is still unexplored. Okay, so the first one was about the generation of the black hole, which we have talked about, and another one part which we are going to discuss, that how the AI-based assistants and robot can play a pivotal role in this domain. Okay, so for example, scientists are gradually developing the AI-based assistant to aid the astronaut in terms of the making the successful their mission in terms of going towards the moon or the Mars or beyond of that. So it can help the crews which are present there, okay, or the astronauts. And so what will happen in that case, they can also capture their emotions, mental health, and if required, they can provide the necessary actions. So the sentiment analysis, all of you quite aware of the sentiment analysis, which we sometimes call as the opinion mining, in terms of AI, you call it as the emotion AI. So this is a very important part of the natural language processing NLP, which helps to identify and extract the opinions, okay, as per the going through the text, okay. So like the social media or from the forums or from the blogs. So these NLP, special category of NLP applications, sentiment analysis applications will be explored to see that how the on a certain situations while doing the space travels, how the astronauts are reacting, how their mental health is doing. So in overall the emotion, they will capture the emotion and mental health information with the help of this kind of the sentiment analysis. Okay. So along with that also another important part which may be explored in this kind of the AI-based assistants and the robots. On the other hand, that you can put in many cases what happens that they may become much more handy to providing the help with the physical assistance, which can be piloting the spacecrafts or the docking spacecraft or handling the extreme conditions which are not being safe for the humans. Okay, so in those cases also, this kind of the AI-based assistance and robot can remain helpful. So in the first case, we have seen the benefits of the generation of the black hole image with the help of the AI algorithm. Then we have seen that how the other possible ways through the sentiment analysis and other type of the assistance through the AI and AI-based applications can be possible. Okay, so another interesting area which we are going to discuss, that would be the intelligent navigation system. Okay, so in the intelligent navigation system, what will happen that as per the report from the NASA that they are basically with the help of the Intel in 2018 they have developed such an elegant way such that astronauts can find with the high precision in terms of their way on the planets. So this navigation system, what will happen that whenever you are basically going towards the surface of the planets, so it will give you the shortest route, okay, shortest possible route. So that is very much effective in terms of whenever you are making the space travels. So already the scientists have applied this particular program to, for example, in our moon mission, okay, and it has worked in terms of with the high precision, okay, while landing up the moon surface and all those things. So the many AI algorithms has trained with the millions of the moon's images, and then they have used the neural network for creating the virtual moon's map. Okay, and these same algorithms are also being applied in terms of the Mars exploration program. So already that has been tested for the high navigation purpose and providing the shortest route while doing space travel. So that has a lot of interesting applications. And if you see, this is one of the moon's 3D model which has been generated, and thanks to the NASA for this picture purpose. So this is basically one of those cases which you can see. And another important part which we may discuss, that is basically the discovery of the Kepler exoplanet. Okay, so in case of the NASA's Kepler telescope that was basically designed for determining the frequency of the Earth-sized planet orbiting the sun-like stars. But these planets were very edge of the mission's detection sensitivity. So whenever you are planning to determining the occurrence rate of these planets in terms of the which is required for the automatic and accurate assessing of the likelihood of the individual candidate, that can be performed with a low signal to noise ratio. So that is another very great improvement in terms of the discovery of the Kepler's exoplanet. So to overcome this kind of the limitations, what has happened that the researchers, for example, they are working in Google or the other scientists, they basically developed the help of the deep learning framework that is basically convolutional neural network, which we call CNN, which is named as the Astronet K2 for the predictions whether a given signal from the Kepler Space Telescope that is basically transmitting the exoplanet or the false positive caused by the astrophysical or the instrumentational phenomena. So by training this algorithm, what they are getting, they have checked that 98% of the accuracy which is possible. So they successfully identified two exoplanets, namely, for example, Kepler 80G and the Kepler 90I, orbiting the Kepler 80 star system and the Kepler 90 star system, respectively. So this astronaut K2 has been really a great success, what they have developed with the help of the Google and the other scientists. But the base of this application was the CNN. Okay, so that's the reason I'm saying that the flourishment of the deep learning era from 2012 onwards has given us a lot of help. And in terms of the Web 2.0, since the Web 2.0, we have seen the cloud-centric technology. We have the lot of space in cloud to store data that was not available earlier. That's the reason LANet failed in our late 80s, which I explained during the beginning of my talk. So due to that, you can process the millions of images all together, and you can develop a robust algorithm which can help in terms of this kind of the critical space cases as well. So we can also talk about the another interesting phenomena, that is the space debris solution. Okay, so as you can see, this the space debris around the Earth. Okay, so these are the areas which you can see in the screen. So these are the space debris. Okay, so that in that cases, how AI is helping us, that we are going to explore. Because if we see so far that we have talked about the few of the important cases, like right from the beginning, if we see, we have started with the talking about the black hole images. We have talked about the AI-based assistants. We have discussed one of the cases, like, for example, the intelligent navigation system. Then we talked about the another important part related to the discovery of the Kepler exoplanet. And now we are seeing the another interesting case, that is the space debris solution. What are the possible solutions, robust solutions provided by the AI-based algorithm for the space debris cases? So in that case, what will happen, that the problem in the space debris has reached a particular critical point, as the scientists and researchers continuously sending the satellite to space. All of you may hear that across the globe, everybody is taking their attempt in terms of sending the satellites into the space. And the problem is that that is being never brought back. So due to that reason, what is happening, that nowadays more than 23,000 human-made fragments are available in the space, which is larger than 4-inch and more than 5 lakh small particles. So that is a massive amounts, and that has created a really problem whenever you are making this space travel. So there are always a chance to collide with the satellites or the spacecraft. So they leave a dent on the body of which may sometimes provide the primary reasons for the space accidents. So due to that reason, what is happening, that in the space debris are creating a major threat for this kind of space accidents. Okay, so that is a really physical threat which are faced by the space scientists. So what can be the possible way to get rid of that? So to overcome these problems, the scientists are gradually planning to develop with the deep learning-based algorithms, okay, to enhance the accuracy of the laser ranging technology, which was critically used earlier. And they use the backpropagation neural network model in terms of the pinpointing the location of the debris. Okay, it was also mentioned that while you are improving the pinpointing accuracy of the telescope through a deep learning technique, this debris with a cross-sectional area of 1 square meter with a distance of the 1500 kilometer can be identified correctly. So that is another important part. Okay, that's the reason I told you that how this deep learning era is trying to give you the proper shape in terms of the improving the accuracy. And as you know that in deep learning, we use the ReLU as an activation function. Leaky ReLU is also giving you the further benefit in terms of the avoiding the vanishing gradient problem. So what is happening that you have a ramp-like curve. If you study deep learning, you'll see that in comparison to the machine learning activation function which you use, basically, for example, sigmoid function or the tan hyperbolic. So in deep learning, we go for the ReLU. Even the reason, another reason of the LANet which held in 1988 was that in the deep learning model, they have used the sigmoid function as an activation function. But in deep learning era, from the 2012 onwards, people went towards this performance-wise scalable activation function. Okay, so something like, for example, ReLU, which can give you the optimum accuracy. So in that cases, that has given you the performance-wise scalability. you can take your accuracy even nearby 100%, because what happens that deep learning, if you have the data set on around 10 to the power 5, it will really do well, because the activation functions which we use in case of the machine learning, that is, for example, if you are exploring the sigmoid function of the tan hyperbolic, so their performance gets saturated whenever you have the data point nearby 1 lakh. Okay, so in that cases, if you were exploring with the deep learning like framework, so that is going to give you a better result. So in space technology domain, where you deal with the high volume data sets, okay, in those cases, high performance computing plays a very, very important role. And in that era, that's the reason in many kind of the applications, like this is a serious problem. The space debris, providing space debris solution is a serious problem. It is under research, but still there, whatever the success is has been got by this deep learning technique, that is promising, because they are being able to deal with the space debris with a cross-sectional area of the 1 square meter and a distance of the 1500 kilometers accurately. So that is a very promising approach which has been made by the space scientists and along with their data scientists. Okay, so that has a really proper applications. Now the applications of the AI in space sciences, which we have seen so far. So those who are interested to explore in this domain, those who are new to this domain and planning how to start your application, how to start and explore with the data set. So there are many cases which I have highlighted. Apart from that, these are the major cases in space technologies as AI has explored. But apart from that, NASA provides the terms of the open source libraries. Okay, so there are, you can deal with a lot of space science related and space science technology related challenges. So in those cases, you can actually use the NASA's most powerful library, which is available, that is the SPICE. Okay, so in that cases, you will see a lot of explorations of the C forerun, and the Python wrapper is also used there, which we call as this spicy byte. So these are available there. So you can check out whenever you are exploring in this particular direction. Okay, so this will give you a lot of idea that how the interesting challenges are coming up in the space technologies, and how you can actually explore your data science knowledge in that particular domain to give an optimum result. Okay, so these are the main areas I wanted to talk about in today's topic. So thank you very much. You can join me in my social media handle as well, and let me share some of my data science related resources which may be useful for those who are the data science related enthusiastic. So for example, you can subscribe my YouTube channel as well. So there are some hands-on sessions related to the data science are also given. Okay, so it might become very helpful to all of you whenever you are exploring the data science cases. So this is my link of my YouTube channel, and also let me share my Medium account. So I shared few of the articles there. Gradually, I started for the students so that they can remain benefited. Okay, so some of the career-related informations which are given there. And along with that, also let me share my GitHub repository. So you will figure out the lot of machine learning and deep learning related stuffs which we are gradually exploring. So those who are new in terms of the in this particular field, they can explore, they can learn a lot from the data. Okay, so I am gradually uploading the data sets also. If you go to my GitHub, you will see a lot of imaging resources we are giving there, because I know whether you are going for this space sciences, you have to deal with the images. So you have to be very much good in computer vision as well as the basic image processing, because in the data, what happens that you may go for the machine learning, deep learning, but data pre-processing is a very important part. Okay, so try to understand that if you are doing this star detection. Okay, now what happens that in star detection, a lot of salt pepper noise will be there. So if you use the median filtering, then you can remove this salt pepper noise. But you should have that knowledge. Okay, so data, you should have the knowledge on the data resources. So that is the reason a lot of tricks and techniques are there during data pre-processing. Sometimes you have to do the background extraction and all those things, how to deal with the missing values. So due to that reason, data pre-processing remains very, very important part. So statistical details also available in my GitHub. You can go there, you will see that how to explore the statistical problems in Python, and then image processing related stuff are there. Machine learning, deep learning, I'm gradually uploading in those repositories. So once your base will be strong in this domain, you can easily handle the space science related problems. So, and in this PPT, I have highlighted few of those major areas. I will share the PPT with all of you, all the participants. So it will help you in terms of the understanding the major challenges present in space science and how can you explore AI/ML in optimum way in space science. So thank you, those who have acknowledged me. I have tried my level best because let me tell you, I basically explore AI/ML majorly in case of the biomedical domain, in sometimes weather data set, but I am not an active researcher in this domain. But from my basic knowledge on the data science and all those things, and my basic idea from the space science, I have tried to give an overview for the newcomers, those who are the new in this field, that the major challenging areas. Okay, so those areas, if you follow the basics of these things which I have talked about, like machine learning, deep learning, as well as the computer vision part. If you go to my GitHub repository, you will see there is one repository is digital image processing, so you can explore it. Okay, so you will get a lot of insight to how to process the data, because image processing is the major pillar of the computer vision. Okay, so it will help you a lot, I believe. So okay, so thank you very much for your acknowledgement. Thanks a lot for listening to me, and you know, few things which are not in our hand, you know, some network issues and all those things. So very sorry for that, for the initial interruption purpose, but thanks for your patience that you still bear with me. Thank you very much.
Thank you, sir, for this wonderful session. Now, I think we can move on to our Q&A session for today. So participants, if you have any questions, please feel free to ask, sir, or you can also write in the chat and I'll be reading out the questions. So I also do have a question. So I think this is a question for a lot of viewers, for a lot of participants, that if we are a newcomer to this field, then of AI/ML, then what should be our basics? Like, what are the basics that we should learn? Or
oh, sure. The thing, like I mentioned, that you should have a very strong grip in statistics. Okay, so it descriptive as well as the inferential, both the part you require to know. And along with that, probability knowledge will be important. Like I showed you, that the chip algorithm has been used for the black hole image detection purpose. Now you see, those who are not aware of the this basic part of the Bayesian probabilities and all those things, they will not be able to understand this Bayesian model, because this chip algorithm is completely based on the Bayesian formulation. Now you see, if we talk about the Markovian model, hidden Markov model, all are the Bayesian model. Naive-Bayes algorithm, okay, which is a basic Bayesian application. So any noisy system, whenever you are working, those people who work in optical tweezer domain, they also know that for the noisy system, you have to go with the Bayesian model. Bayesian model works very well. So to understand that, you require to understand the probability pretty much well. So that's the reason probabilistic understanding is very, very important in terms of data science angles. So one is statistics, second one is the probability, okay, and also another important part that will be required, that is the basics of, first you have to go through that, and basics of the linear algebra, because you see in linear algebra, basic problem solving cases like what is eigenvalue, what is eigenvector, that will give you a basic idea. Okay, because on the basis of that, the principal component analysis, which you learn later in machine learning, so in that cases, how this you will be able to interpret that, how this eigenvalue is becoming so much important in those cases. So due to that reason, linear algebra plays a very, very important role there. And then gradually, once you go to the machine learning, you have to understand that the significance of the sigmoid and the tan hyperbolic curve, that they are not performance-wise scalable. So you require a performance-wise scalability curve like ramp function. Then later, mathematical development has happened and people understood the importance of the ramp function, and then in deep learning. So gradually, once your base is very much strong in probability, statistics, and linear algebra, you gradually proceed with machine learning, then you go to the deep learning. Okay, so proceed step by step. And in the meanwhile, if you are interested in imaging, to master the imaging techniques, it will be very good to make a very strong concept on the image processing, because image processing is a strong pillar of the computer vision. And you will see that many job roles in this world are coming out. in terms of the deep learning engineer, computer vision scientist. So in that aspect also, you can have a lot of opportunity. And you know, especially in space science, whether it is in NASA or in ISRO, nowadays a lot of people from the data science backgrounds are being hired because of that. Because you know, nowadays data science is a hot cake because of this kind of a lot of flourishment of the job opportunities. But you have to master, because one thing you have to understand, that it will not be the same thing. The way you will process the time series data, you can't process the same way in case of imaging data. So you need to learn the techniques. So that's the reason I have shared my GitHub link, and I told you to visit the digital image processing repository to master yourself on the basics of the digital image processing. Otherwise, you will not be able to handle those space data. Okay. So due to that reason, these are the very basics part, so which you may cover up. And let me write in the comment box as well. So first of all, statistics, followed by probability, linear algebra, machine learning, then you go for the deep learning. Okay, and those who want to master the imaging techniques for the imaging case, make sure that you have a very good understanding on the digital image processing.
Okay, sir. Thank you.
The basics of that signal system you can go through. Those who are from the engineering background, they basically, during their semester, first of all, they basically taught, for example, electrical engineering or the electronics communication engineers or the computer science engineers, they have one papers on the signal system. Okay. So make sure that you are going through this paper well, because you will have the 1D idea. Okay. Because once you understand the 1D signal, then in terms of the image, you will be able to understand the 2D part. Okay. In few cases nowadays in the BTech curriculum, people are also introducing video processing part, 3D part as well. So in that case, you will be able to, but the basic is right from the signal system. Okay. So it will help you to understand the very basic things like the Fourier transform and all those parts. Okay. So what happens that, for example, you are capturing one image. Okay. Image of a flower. Now what will happen that whenever you are capturing the image in spatial domain, what happens that lot of unwanted stray lights also interferes with the original signal. So signal and the noise are remains in a spatial domain convoluted format. Now it is the image of flower, but for example, you want to detect some critical cases, for example, in healthcare, skin cancer. Okay, so you want to do a developing mobile-based app for detecting the skin cancer. Then what will happen? Once you are capturing that image in spatial domain, signal and noise remains in a convoluted format. Okay, so once you process them by doing the Fourier transform to the frequency domain, what will happen? They will become in a multiplicative format. So it will be easier for you to remove the noise from the system, and then you will apply some machine learning, deep learning techniques on it. But to process the data, like I told you, that you have to understand the resource of the noise. If you are using any laser-based setup, which is very common in biophotonics and space sciences, everywhere, which is a very common thing. It is the resource of the median, it's the resource of the salt-pepper noise. So how to remove that noise? So you have to understand the pattern of the noise, how they are interfering with the signal. Majority cases, they remain in additive format. But when the stray light interference comes, spatial domain, signal and noise remain in a convoluted format. So if you study the signal system, and even in image processing, it is there. Signal system, it is for the 1D case, image processing you will get for the 2D case. That in convolution theorem, according to the convolution theorem, if it is in a convoluted format in time domain or the spatial domain, it will be a multiplicative format in frequency domain and vice versa. So you will be able to understand the importance of the Fourier transform, impulse function, and all those things. Dirac delta function. This is an impulse function. We call the Dirac delta function as the impulse function. So all those things for the 1D case, 2D case, and this will give you the insight that how the signal is behaving. And once you can understand the behavior of the signal and their effect, for example, 2D cases, it will be images. So then only you will be able to understand how to pre-process the data elegantly. If your data pre-processing is not perfect, let me tell you, whatever the elegant algorithm you may use for the machine learning, deep learning, it will not give you the correct result. So data pre-processing is utmost importance. And that's the reason I'm telling you to go through statistics properly, understand the necessity of the statistics, understand the necessity of the signal system, digital image processing, okay, and then it will help you to lead in your career. Because I am telling you, this is a very lucrative, there are a lot of lucrative job opportunities, high salary job opportunities are there, okay. But the thing is that your basics should be very strong, because people will ask you very basic questions, which you have to answer it, okay. And another important part that in some cases, let me tell you that there are two types of the data sets that are available. Okay, you have to understand that. Two data sets. For example, if you yourself is collecting the data set, that is called primary data. So when you are capturing the data by yourself, so you yourself know that what are the proper resources are available. Okay, for example, if there is some noise interferences, what are the instruments you have used? You know that this is my instrument. It has certain trade-offs and limitations that may land up with this noise. But once you are downloading the data, for example, if you are downloading the data from GitHub, okay, or some other resources, you do not know that how the data has been captured. What are the noises are there? So in those cases, okay, let me tell you for yourself also, you may upload some primary data, but whenever I am downloading it, it is the secondary data to me. You have done some, for example, some experiment and you have collected some data. That is primary data to you. But whenever I am downloading it, it is the secondary data set to me. I do not know what are the things, how you have calculated, how you have captured it, what are the approximation you have made for capturing the data. Okay, so I do not have that idea. So I do not have the knowledge what will be the possible noises on that data. I will only guess as per my expertise and I will try to remove the noise. So it is always better if you can add some data description there, that how you have captured the data apart from the data sizes. Okay, so that will help you a lot. So that's the reason I'm telling you that you have to make the understanding of the primary data set and the secondary data set. Okay.
Thank you, sir, for sharing everything in like so much detail. Now I think we can move on to our next question. We have a question from Shreya Anand. Shavas, sir, I have one question. You mentioned applications about training at the AI through datasets. Can you also throw some light on applications using reinforcement learning in aerospace industry where it does not require training large datasets?
So if I'm telling you to go through my article in Medium, okay, what are the career opportunities are there in reinforcement learning, you will be able to understand. Okay, go through my article, you will get the answer. And the next question, David Clark has asked, how can we coexist with machines that inherently lack human values? Well, you see that you have asked a very philosophical question, Mr. David. You see that it is the matter of the policymaker and the government as well. Because you see, nowadays, let me tell you, a simple example. Robotic process automation, all of you have heard. This is one of the pillar of the AI. Okay, so it is an automation tool which can send 20,000 email per day to some rigorous sections. It works. Now, all of you know that in marketing analytics domain, people deal with Excels. Okay, a lot of people are doing Excel-related work. So, what will happen that if you replace all those people, marketing analyst people, with the RPA? RPA is a robotic process automation, although the name is robotic, but it is not a physical, it is a software robot. Okay, because it can do the superhuman activity. People have given the name that it has the robotic process automation. In short, we call it as RPA. Now, if you put it in the office, the RPA software, and it is replacing all the marketing analysts, then what will happen? People will lose the job. So, but should we stop using RPA? No, because we will require that. It is not possible for a single human being to send 20,000 emails per day, but it is the role of the policymaker and the government how to implement them. Are you getting my point? Because if you launch all those AI-related stuffs, robots in the market, it will replace human definitely. But in what extent we should use? Because we have to keep the scope for the human to exist, because they have to do their job, right? So how much we should go with this kind of automation-related stuff, and how much we keep the human, that should be trade-off. And another important point is that at the end of the day, you may deploy robots in everywhere, algorithms everywhere, but some human will be there who actually controlling those algorithms. So job scope will be there, but I am talking about smart level, because you have to understand across the globe there are more than 80% people under the bottom of pyramid category, and in India it is more than 96% people who are under the bottom of pyramid category. That means these 96% people do not have enough money to pay tax, and across the globe 80% people do not have enough money to pay tax. So you have to understand the market value. Whenever anything is coming up, it is a responsibility of the government and policymakers to think that, okay, technology is blessing to the society, but how much level we should deploy the technology so that people should not lose the job. So it's a very philosophical question. I hope I have given you some idea that how we can coexist with the machines. Okay, thank you very much for that question. And the next question is that if we increase number of filters in CNN to understand the image better, will it make it the model? Yes, definitely. Definitely, time complexity is an important part. Let me give you a simple example case. Nowadays, we are going to the lightweight model. If you are talking about CNN, I am talking about depth-wise separable CNN. You can search in Google depth-wise separable CNN, how you are reducing the time complexity for the lightweight devices, like for example, a smartphone like mobile phone. How can we reduce the time complexity there? So that's the reason one important part, thanks to Mr. David Clark, I remember, I forgot to mention, that those who are studying engineering, even in computer applications related stuff, nowadays even in science studies also, one paper people are incorporating, that is basically the data structure. Right? Read the data structure properly, otherwise you will not be able to develop the algorithms in an effective way. Okay, so you have to understand how to reduce the time complexity for the lightweight model, how to reduce the space complexity for the lightweight model. So as a reason, understanding of the data structures will play a pivotal role. I am giving a very simple example case. Okay, so for example, I am processing an image n by n. Okay, so what will be the time complexity? Those who have the basic understanding of data structure, they can say, sir, it will be order of n square. Fine. Now, like why I told you to go through the linear algebra properly, because even in deep learning step, like Mr. Clark had asked, in the final step, you will go in the CNN, that is a flattening technique, that we call the flattening. Actually, in flattening, what we do, we are doing the vectorization. So if we have the pixel values, like for example, ABC in first row, DEF in second row, it will imagine is nothing but a matrix format, right? So if we unfold them, we can unfold them in horizontal direction or vertical direction, either row-wise or column-wise. What will happen in that case? ABC, DEF, all those things will be in one row or in one column. So that trick in terms of linear algebra, it is called the vectorization. So it is existing much earlier. Rather than processing the 2D image altogether, you can convert it into 1D data and you can analyze it. It will give you much more hidden features. So those are the very basic steps of the nonlinear dynamics, which has been adapted by our godfathers of the deep learning while giving it in the flattening state. Okay, so my objective is that if we convert the 2D image n by n image to 1D data, then what will happen? The time complexity of the data processing will reduce from order of n square to order of n. Apart from it, in getting the much more insightful information from the data, your time complexity is reducing. So that type of the trick you require to understand. That's the reason, if you see classically, those who are being hired for the data analyst position and those who are hired as a data scientist, why there is so much salary gap? Because data scientists will not only do the data analysis, but they will contribute in algorithm. And that would be, to now today's era, that is majorly for the lightweight devices, that how to reduce the time complexity. And that has the very basic tricks of the linear algebra and the data structure. How to reduce the time complexity from order of n square to order of n. I have given you a very simple case example. Okay, so these things you have to keep it in mind, that how to deal with the low processor device, because in case of the high processor device, you have the processor power. But if, for example, if I am taking a mobile phone and I am implementing edge computing, because today there is the edge computing era, then how can we process the data because my phone will not have that much of processor power. So that insight you require to understand. Okay, so that's the reason you have to use your clever tricks and techniques, and that's the reason as a data scientist you will be your job salary will be so much highly paid. Okay, and that is one of the classic example why classically, if you make the comparisons between the salary of a data scientist and a data analyst, why there is so much difference. Because data scientists not only do the data analysis, but they are keeping the algorithmic insight. Okay, they are contributing in terms of the algorithm development. Okay. Now, okay, so fine. I think Mr. Clark bot has his answer. Okay, so Mr. Clark, you go for the depth-wise separable CN. Depth-wise separable CN. I'm writing in the comment box.
Thank you, sir. We also have another question from our YouTube chat. Integrated Boys the Bus, what will be the best model or models for identifying asteroids?
Well, see, basically, first of all, this is a question related to the pattern recognition. Okay. So now the thing is that any applications, like I told you, that whenever you are using the machine learning or deep learning based algorithms, first you have to basically go through that. What are the quality of the image you are getting? Okay. So whether that is a low resolution image or the high resolution image, if it is a low resolution image, you have to go for the basically different kind of the contrast enhancement algorithm you have to use. And then once the pre-processing steps are done, you have to check that what are the noise factors are there associated with it. You have to apply it to remove the noise. Like I told you, in many cases, the star detection purpose, there are very common problem with the median filtering. So these pre-processing steps you have to make it correct. And then you have to check the data set size. Okay, what are the data set size are available? If I am considering that if you have large volume data sets like the 10 to the power 5, so you can go for the CNN based approach, because nowadays in the astrophysics domain, majority of this kind of the detection problem, lot of CNN based algorithms are being explored. So even today I talked about one of the CNN based approach, that is the Astronet K2. Okay, so that also may become very useful. But the basic funda is that to know the deep learning and applying of this CNN. But while doing that, I want to highlight one important part that is related to the feature extraction part. That is very important part, apart from the data principles. In machine learning, what will happen? That you will explore the feature extraction part externally. Okay, for example, I'm giving a very simple case example. Like you are using PCA for the feature extraction, followed by some support vector machine for the classification purpose. But you have to apply it externally. But whenever you are doing it for the deep learning based approach like CNN, you will have the convolutional layer, pooling layer. In this way, you will go further. So it will help you to automatically capture the high features of the data and drop which are not important. Okay. So classification, so feature extraction followed by classification intrinsically happens there. Are you getting my point? So first see what is the data size. Okay. If we have the 500,000 samples, apply feature extraction tool, then you apply machine learning 5. If you have a very high volume data set, okay, 70,000 images, 1 lakh images, whenever you are going 10 to the power 5 or beyond, then go for the deep learning. Okay, convolutional neural network will give you a better result. No problem. And like I also want to remind you, make sure that you are doing data pre-processing correctly. You will get much more better result. Okay. Thank you.
Thank you, sir, for this wonderful session. Now I think we can move on, end our Q&A session here for today. So firstly, I'd like to request everyone to turn on their camera once so that we can take a picture. Thank you, sir, for this wonderful session. Thank you for joining us and giving us your time. We are really grateful. And secondly, I would like to thank all our participants for joining us today. Also, we will be launching our 2 masterclass sessions. Firstly, one on astrobiology, which will be at the end of this month from 26th to 29th. And also, we'll be launching a space law masterclass session on 2nd of August to 3rd of August. So I hope everyone, those who are interested, can visit the website and register to participate in the masterclass. Thank you, everyone.
Thank you very much for inviting me here. Thanks a lot. Thank you very much.